Okay, this is section 6.1, page 333, graphing systems of equations. But before we get to graphing systems of equations, you need to understand kind of the big picture, okay? First we have to understand what is a system of equations. I mean, if we're gonna graph them, what are they? Okay? Well, an equation right now, the equations that we're going to talk about are linear equations. So if we graphed them, they are lines. So we have a system of them. We have two or more lines. So a system is two or more lines. Okay? So we're going to concentrate on two systems, or two line system. Let me say it that way. So two lines in a system. Do you understand? So we're going to have two equations, all right? So think about two lines. Just picture in your head two lines. What do the lines look like?
Parallel.
They're parallel. Okay, so one of the ideas is that we can have parallel lines, okay? Now, just so you know, in geometry, which is next year, we put an arrow in the middle, and that represents to whoever's looking at it that this is parallel. All right, parallel is spelled P-A-R-A-L-L-E-L. Since I'm spelling it for you, what do you think?
We didn't know how to spell it.
You need to know how to spell. So this is parallel lines. Okay. What else do you see? Yeah.
Like two lines that like are an X.
Okay. So two lines that do this.
Intersect.
Okay. What do we call those?
Intersect.
All right. These are called intersecting lines. Okay. Intersecting lines. Can anybody think of another thing? Yeah.
Perpendicular ones.
Okay. But isn't that the same as intersecting?
I thought.
But it's a special intersection, isn't it?
Mm-hmm.
Okay. But it is intersecting, right?
Yeah.
Two lines that intersect, perpendicular, are intersecting. There is one other one. And this is where we take, see that line? All right, so that's one line, right? And then I graph the second line, and it goes exactly over the first line. So it looks like there's one line there, but there's really one on top of the other one. Now, you would have never guessed this probably, huh? No. But these are called coinciding lines. Okay, so we have parallel lines, intersecting lines, and coinciding. Coinciding is C-O-I-N-C-I-D-I-N-G. It's coin and then siding, right? Do you understand that? All right, so let's talk about this. These are systems, right? All right. So how many points of intersection does this system have?
No, zero.
Right. So this has what we would say no solution. In other words, if we're looking for a solution of the system, this one has none, right? All right. This one has none. Okay. Since it has no solution, all right, it has a name for the system. The name for the system is an inconsistent system. All right, so it's parallel, it has no solutions, and it is inconsistent system. All right. Let's take a look at the intersecting. Does it have a solution?
Yes.
Yeah.
One solution. In other words, it touches in one spot. So can it be inconsistent?
No.
No. It's called consistent. And then it has a really weird word, independent. Consistent, independent system. That's what this is called. Consistent is C-O-N-S-I-S-T-E-N-T. Consistent, independent. The reason it's called independent is the lines are different from each other. They just happen to run into each other, right? Right. Okay. So now they're coinciding. One lies on top of the other. How many solutions?
No. Oh, infinite.
Infinite. One lies exactly on top of the other.
So you're gonna hit
So
it
all
at
their
the
points are a solution. So this has infinite And this is called, well, since it touches at least once, it's called consistent. What do you think?
Dependent.
It's dependent. The reason it's dependent is one line lies on top of the other one. That means dependent. If you're dependent on your parents, that means that you need them, right? One needs the other one. So when we do these, when we find a system of equations, we're looking for solutions, all right? And the solutions are no solution if they're parallel, one solution if they intersect. By the way, that one solution we can write as an ordered pair, right? And then infinite solutions. Now we cannot write all the pairs here, so we just say infinite. Do you understand? Okay. All right. So now this is what a system is, right? But how do we find this? How do we find these things out? How do we find out if the system is parallel, intersecting, or coinciding? How do we find that? Today is graphing, but there are other methods, all right? All right, so there are some methods to finding the solution of a system. Okay? And we are going to learn in this class 4. In Algebra 2, I think we add 2 more. All right? So the first one is, we're talking about it today, is graphing. And you know what the wonderful thing about graphing is? It's a picture. You know that old saying, a picture is worth 1,000 words? It's funny, I can say, we can do the graphing method, and I can say, what are we talking about today? So what were you talking about? Lines that intersect. When I do the rest of the methods, I say, what are we talking about today? They'll go, I don't know. We're just finding a point. Well, what's the point? Well, I don't know. I said, well, isn't the point where 2 lines intersect? Oh, yeah, that's what it is. Whenever you have a picture of what's really going on, you understand fully what's going on. When you don't have a picture, you kind of have to piece things together, don't you? A picture. That's the good thing about it. All right, that's a smiley face. We can see our answer. We can see it. It's physical. The bad thing about graphing, it's not always accurate. In other words, we may have a line intersecting another line in between somewhere. We have to guess what the solution is. It also is a little bit time consuming. What does it mean to be time consuming? Takes a long time. All right. To graph lines takes a long time. The second thing, the one we're going to do, is called substitution. Okay? What's the problem with it? Can't see it. So we can do substitution, and I can say to you guys, hey, what are we doing? Oh, we're doing substitution. I said, well, what are we finding? Well, we're finding an ordered pair. And I said, what about that ordered pair? I don't know. What do you mean you don't know? Well, I don't know what it is. It's just an ordered pair. I said, well, isn't that where 2 lines intersect? Oh, yeah, that's right. Because we don't draw a picture, we forget that's where 2 lines intersect. Got it? What are the advantages of it? Fairly accurate. It can be rough, though. Not always easy. We want easy, don't we? To find something, we want easy, don't we? Okay? Okay, the third method that we're going to use is elimination. Once again, you can't see it. So it becomes a problem. We forget what we're actually doing. Right? It is very accurate, and it is fast. Everybody likes elimination. If we can figure out what to do, it is awesome. It is awesome. Okay, the last is, how did I say that? Matrix. I'm gonna say it the same way every time. Augmented matrix. Okay. Okay. Well, I'm just gonna be honest with you. Most students do not like this one. Okay, can't see it? It is slow. And it's somewhat confusing. It's called augmented. The word is augmented, augmented. It's kind of a different word, okay? Yeah. The nice thing about it, we use matrices more now than we've ever used them, okay? And I will talk about a matrix when we get there, and you'll understand a little bit more about a matrix. But for right now, you're just gonna have to take my word for it, I guess. Okay. All right. Any questions about what we've done here? Okay. So I'm going to go back here because it's easier to graph if I'm doing the work right here, because it's right beside the graph. So I'm going to do the work here. What method are we doing today?
Graph.
Graphing. All right. So we're going to solve using the graphing method. So your directions might say something like solve each system by graphing. Okay? How many lines do we have here?
2.
2 lines, okay? Which one is in slope-intercept form?
Second one.
The second one, so we don't have to do anything with it, do we? Okay, what do we have to do with the first one in order to graph it?
3x to the other side.
Okay, so we gotta solve for y, is that correct? Would you do that, please? So I'm gonna take the first one. I'm gonna go ahead and just put an oval around this one because I know it's done. I'm gonna take the first one. I'm gonna subtract 3x from both sides. And I get y equals plus a negative 3x plus 10. Do I have to divide by anything? No, this worked out really nice, didn't it? Okay. I do not have to divide by anything, do I? Okay. In fact, I have them, right? If this was a 2, I'd have to divide by 2, wouldn't I? Okay. So now I'm going to take my straight edge, right? So you'll get out your straight edge. And I'm going to come over here and graph it. Okay? I'm going to turn this just a little to make sure that we get it on there. Okay. All right. So we're going to graph the first one. Actually, the first one is the second one, right? But we're going to graph this one. It doesn't matter which one you do first, okay? We have a y-intercept of what?
Negative 2.
Negative 2. So we're going to go down here. We're going to go negative 2. We have a slope of 1, right? So we go up 1 over 1, up 1 over 1. It's really, it really works to your advantage the more points you put on there because it's easier to graph, it's more accurate, and also it might help you with your answer, okay? So that's the first one. Is that correct? Okay. Is everybody with me so far? Okay. The second one has a y-intercept of what?
10.
It's way up there, isn't it? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay.
Dang it.
And then what's my slope?
Negative 3.
Negative 3 over
1.
1. So I go
Down
down 3.
over 1.
over, which way?
Right.
Right, okay, so I go down 3 into the right one. Now watch this, I'm a long ways from my other line. Watch this, I just keep going down 3 into the 1. Guess what happens?
Get inside of it.
I run into it, don't I? In fact, I run into it right there, which is really nice. 'Cause
Right where the point is.
right where the point is, that's sweet. And then I draw that line. Okay, now that is not my answer. That's the method, right? My answer is what?
Intersection?
It says solve each system by graphing. My answer is,
Intersecting?
no, that's the
3-1?
3-1. My answer is 3-1, okay? It intersects in 3-1. Now, what kind of system? This is not part of the question, but you're gonna have this question, so I want to begin to answer it. What kind of system is it?
Intersecting?
No, that's what it does. What kind of system is
The
it?
consistent independent.
It's consistent, independent. I'm gonna write that. It's consistent, independent. If I ask for the system, then you have 3 answers. You have inconsistent, consistent, independent, or consistent, dependent. Okay? Those are your 3 possible. And if I ask for the system, if I say solve by graphing, I want the 3-1, right? Any questions? Yes, sir.
So, like, because it's an independent, that won't be an answer.
It might be if they ask what kind of system is it. Did you hear him? If they ask for you to solve it, it's an ordered pair. If they ask for you to tell you what the system is, it would be consistent, independent. What type of system it is. You got it? See the difference? Okay. Let's try another one. Let's keep the same directions. Okay. All right, let's try this one. This is number 2, right? Oops, copied the wrong one down. Okay, what's wrong with these two, Nadima?
They're not in slope intercept.
What a great answer. They're not in slope intercept form. Perfect. Couldn't have said it better myself. Okay, so we're going to solve each one for
Why?
y. All right. So would you start to begin to do that? I'm going to do it on the board here. I'm going to do it left and right. So. I hope Abby can hear this. We got the microphone. Ooh, look at this. -1 plus -2x, and then divide by -1, divide by -1, divide by -1. The first one I got y equals 2x plus 1. Let's take a look at the second one. I'm getting y equals -3 plus 4x, no, 2x. It's 2x. Okay, so I get y equals 2x plus -3, is that correct? Okay. Okay, anything you notice about those two lines?
2x?
They're both 2x, so what does that mean?
They're the same slope.
They have what?
The same slope.
They have the same slope. So what are you guessing for these lines?
They're gonna intersect.
They what?
They're gonna intersect.
You say she says they're gonna intersect. She says they're parallel. Which do you believe? They're gonna be parallel because they have the same slope, okay? Now, hold on a second. Before you start doing this, let's continue on that same mode. They're gonna be parallel, but they're gonna touch the x-axis at different points. Or excuse me, yeah, they're gonna touch the y-axis at different points, I'm sorry. Right? So they're gonna be parallel, right? We have another set of lines called coinciding, right? How would these two have to change to be coinciding?
The y-axis are the same.
Yes,
They have to be the exact same line.
exactly. Both of you are right. He said the y-axis has to be the same, and then she says they have to be exactly the same. Very good. They would have to have exactly the same equation, wouldn't they? When you solve for y, right? When you're done solving for y. They won't look like it when they're up here, but down here they're going to look the same, exactly the same. So you just graph one of them, right?
Yeah.
Okay. So just out of curiosity, do you need to graph these in order to answer this question?
No.
No, you don't. Nadima said it. Taylor said it. Okay, you don't have to graph them. What is my solution?
No solution.
What is it? Anthony, louder.
No solution.
No solution.
You don't even have to graph it then?
Well, I'm going to make you.
Okay.
Okay, but what I'm saying is you don't have... Now stop before you go any further. Okay, this would be no solution. What if these were the same? What would be the solution without graphing? Infinite solution. So when we get a no solution or we get an infinite solution, you really don't need to graph, only that Mr. Ellis makes you graph. Okay? But when they're intersecting is the way we like it, but that really has the problem, right? Because it takes forever to graph. But let's go ahead and graph these. The first one has a y-intercept of 1 and a slope of 2. So I'm just going to graph these. All right, like this. Capiche? We're good to go there. And then we have a -3. Am I going too fast? Then I have a -3, so I'm down here, and then my slope is 2. And so it looks like this. And you can see that they are parallel. Do you remember in geometry what we do? We put a little arrow in between them, and that tells the reader that those are parallel. There is no solution. Now I'm going to refrain from doing a coinciding one. I'll let you finish this up, and then we'll talk.
The third arrow needs to be in the middle.
Yeah, it needs to be somewhere in the middle, but it's not, it doesn't have to be exactly in the middle, and it's another set of arrows, but it has to be on both lines. And that just tells the reader those lines are parallel. Okay? Taylor, do you have a question?
No.
Okay. So, I'm going to refrain from doing a coinciding one because I've already told you that these two lines will be exactly the same, and you will put infinite solutions as your answer. By the way, what is this system called? If the next question was, what is this system? What is it?
Inconsistent.
It's inconsistent. Notice that inconsistent doesn't need any independent or dependent. It is simply inconsistent, which means it doesn't touch. Right? So if my answer is coinciding, I get coinciding lines, my answer would be infinite solutions, and this system would be consistent,
And
dependent. Consistent, dependent. All right? Okay. Now, I'm going to give you time to work on your assignment because it is a little bit time consuming. And if you look on page 336, 10 through 15, the first set of questions on 10 through 15, it says use the graph at the right to determine whether each system is consistent or inconsistent, if it is independent or dependent. So basically, you're going to tell me what kind of system it is. You don't have to graph all the ones that are there. Only problem is you got to figure out which is which, and they label them, which is really nice. So take a look at number 10. Y equals 6.
Oh, it's the blue line.
I don't know what color it is. Let me look. It's number 10 is y equals 6, right? And what's the next one?
Y equals 3x plus 4.
All right, so let's take a look. You say that this is the blue line.
Yeah.
Do you agree?
Right in the middle.
It says.
Because right beside the blue line, there is a thing that says y equals 6.
Which blue line?
It's labeled. You got it? The top blue line.
Yeah.
Y equals 6 is a horizontal line, isn't it? Okay, so then the next one is y equals 3x plus 4. It has to have a y-intercept of 4. So find one that has a y-intercept of 4, and then
It's the purple one.
is it the purple one?
Yeah.
And guess what? You don't even have to figure it out because it's labeled. Y equals 3x plus 4. Now take a look at the purple and the blue line. Do they intersect?
Yes.
So what's their system called?
Consistent.
Independent.
It is called consistent independent. Please learn how to spell those. All right? Okay, now is your number 17 crossed out?
Yes.
Yeah.
Do
No.
not. Okay, if your
No.
17 is not crossed out, cross out number 17.
Is it wrong?
Mm-mm. It's just that it's graphed so far, it intersects so far off the paper that it's hard to graph. So it's just a problem. So I want you to do page 336. Let's turn this. Page 336. Page 336, numbers 10 through 16. We're going to skip 17, remember? 17 through 24, and then 30 through 32.
Yeah, but aren't we skipping 17?
What's that?
Are we skipping 17 though?
Yeah, I got 10 through, oh, yeah, thank you. Good one. Okay, thank you. 18 through 24. All right, yeah, all right. Thank you. All right, good luck. You'll have tomorrow to work on it.